أخبار اليوم.
So let's move to question 2. We have here at the start, the part A, mention an application of. We have Meissner effect. As usual, we are going to underline what we need to underline. We need an application. So we need an application for Meissner effect. Yes, right, magnetic levitated train that can move at high speed. That is a very easy question. The second question, remote sensing. We need an application for remote sensing. Yes, remote sensing is done by receiving all the radiation emitted by the surface of Earth, including the reflected light, but that is not the answer. The answer is, what is the application? How can you get benefit of remote sensing? Yes, to determine the underground resources. So you need to write first to determine the underground resources, and then you can add any details but next to that. The third part here is eddy currents. What is the application of eddy currents? That is very simple. Yes, eddy currents are used in the induction furnace for melting metals. Yes, right. Fraunhofer lines. What is the application of Fraunhofer lines? Yes, they are, of course, they are lines, dark lines in the solar spectrum. They determined what gases exist in the sun, especially helium and hydrogen. Integrated circuits. Give an application for integrated circuits. In fact, integrated circuits are the basis for all electronics, either digital or analog. But especially in your textbook, there is an application for integrated circuits in medical field for prognosis and diagnosis. So that is very important to remember, integrated circuits. And the next part in this question, prove that the torque acting on a rectangular coil of cross-sectional area A carrying a current of intensity I and placed parallel to magnetic flux of density beta is given by the relation torque equal BIAN. That is a proof, and you are very good. So prove or deduce means to find the relation from the beginning. So how could we find that relation from the beginning? Yes, right. We drew the coil. That proof needs a drawing. So you draw, and each, as you know, each that is the drawing. Each side carries a current, and the side AB is affected by a force. As you see, we apply Fleming's left-hand rule, and the side CD is also affected by a force, and this force here, the two forces are opposite, are equal, and parallel forces. So they form a couple, and the couple acts to rotate the coil. So torque acting on the coil is calculated by one force times normal distance. That is good. So one force, BIL, normal distance is the width of the coil, so torque equals BIA. If we have any turns in the coil, so the torque equals BIN. That is the question, very easy, and every part in B, first or second, has 3 marks for that part. The next part of question 2, we are going to, as you see, what happens to the properties, of each material on cooling to a temperature near the absolute zero. So the question here, what happens to the properties? Try to imitate me, try to make like me. I am going to underline or circle very important words in the question. That is very important. So what happens to the liquefied helium? Yes, liquefied helium loses its viscosity at very low temperature near the absolute zero, and it becomes a superfluid. It can climb up the walls of its container. So here we are going to mention all the results. What are the results? Pure silicon crystal. What happens to the pure silicon crystal when the crystal becomes at very low temperature near the absolute zero? Yes, the pure silicon crystal at very low temperature becomes a perfect insulator. all the covalent bonds in the crystal become intact, and the concentration of charge carriers in the crystal almost zero, so the conductivity is almost zero. Concerning platinum coil at very low temperature, what happens to the platinum coil when its temperature becomes so low near the absolute zero? Yes, it loses its electric resistance. It converts into a superconductor. It loses its resistance and converts into a superconductor. Its conductivity becomes so great. And finally, the last part in second question is a problem. Number C is always a problem. 4 resistors of values 2 ohms, 4 ohms, 10 ohms, and 12 ohms are connected to a battery of EMF 6 volts and the internal resistance 2 ohms. It is found that the current through 4 ohm resistor is twice through 4 ohm is twice through 2 ohm. So the idea here, how to arrange these resistors to make the current through 4 ohm is twice the current through 2 ohm. That is the very important point. In fact, to think about this. If you connect them in series together, so the current here will be the same as here. If you connect them in parallel, 2 ohms will obtain a higher current because it has a lower resistance. So that is not the problem here. We need to make the current through 4 ohm twice the current through 2 ohm. So we need to think about that. So 4 ohm must have more current than 2 ohm. So 4 ohm could be in series with the battery and 2 ohm could be in parallel. So the suggestion now is 4 ohms then branched into 2 ohms and then 10 ohms, and in parallel with it we have 12 ohms. Why? To make the 2 branches equal. So the current here, if it is I, it is divided into I over 2 and I over 2. So as you see, the resistor 2 ohm obtained half the current of 4 ohm. So that current is double that current. So the answer, as you see now, 4 ohm, then 2 ohm and 10 ohm and 12 ohm in parallel to make current divides equally between them. And finally, we connect that to a cell. The next part is very simple. How to find, as you see, the current intensity through the battery. To find the current intensity through the battery, so that is very simple. We are going to answer it like that. That is the drawing, as you see. The equivalent resistance now, 12 and 12, the equivalent is 6 ohms plus 4, so we have 10 ohms in the external circuit. The internal resistance of the battery is 2 ohms, so the total resistance, that is the equivalent resistance, and that is the total resistance. Equivalent resistance 10 ohms, but total resistance including the internal resistance, so it is 12 ohms. To find the battery current, we apply Ohm's law for a closed circuit, so VB over total R, so 6 over 12, the answer would be 0.5 ampere, and that is the end of the second question.